We are running slightly behind schedule, so I will rush on to the next speaker, which is Monica Greisbach, who's coming from New York, where she is having a private practice, and she will talk on a hybrid approach to the structural treatment of panel paintings, case studies from American collections. Please.
Thank you. Hello. I'm no longer in New York. I've recently moved to London, but. Thank you. Long-standing traditions in making panel paintings have developed throughout the centuries in Europe. Variations in craftsmanship, availability of materials, and cultural context encourage the development of wood supports with distinct regional characteristics. The care and treatment of panel paintings has developed in tandem with these traditions, both in methodology and practice. By contrast, there are no such long-established traditions for the making or the treatments of panel paintings in the United States. Furthermore, the relative youth of the United States required that American collectors and museums primarily look abroad for artworks. As a result, during my time running a private practice in New York City, there was no one type of panel tradition that dominated. I treated panels of many types and of different origins. These included Egyptian fayums, early Italian and Northern European paintings, Latin American paintings, both colonial and modern, 19th century American paintings, as well as modern and contemporary paintings of many varied formats. The set of issues that these paintings presented were equally wide-ranging, as were the environments in which they would eventually exist. Some belonged to institutions and others to private clients. Some were likely to be kept in stable environmental conditions, while others were destined to be in areas with unstable relative humidity. As a result, creativity and flexibility were required when devising treatments and setting conditions for their survival into the future. The ability to choose from a broad repertoire of techniques was indispensable to me when treating the spectrum of painting types. This presentation will show that techniques from different regions proved to be very useful when designing treatments. The mechanics of each treatment will not be the primary focus here. Instead, the reasoning behind the choice of structural systems will be addressed. A total of 4 treatments will be presented. The first 2 represent well-established traditions in the treatment of panel paintings, one of Italian origin and the other British. The third and fourth projects will be departures from these systems and will show how adaptations were made to meet the particular needs of each project. The first case is a Tuscan panel on poplar by Sebastiano Mainardi, dated to 1507, representing the Virgin and Child enthroned with St. Justus of Volterra and St. Justina. The painting belongs to the Indianapolis Museum of Art, where it had been off public view for about 40 years due to its poor structural condition and visual appearance. The large, extensively insect-tunneled poplar support measures 160 centimeters wide by 151 centimeters high. It was previously thinned to a thickness of approximately 8 millimeters and was mounted onto a heavy mahogany cradle. Records dating from 1952 to the present told of continued problems with extensive buckling, blistering, cleavage, and flaking, with loss to the paint and ground layers. Luckily, the primary areas of the image were spared from the worst damage and are relatively in good condition. Treatments were carried out in 1952, 1965, and 1969. These included consolidation, thinning of the removable horizontal cradle members, coating of the back with wax, and various restorations to the paint layer. Having removed the cradle and repaired the splits, the painting had little structural integrity of its own. This was due to its large size combined with its extreme thinness and the deteriorated condition of the wood. I decided to apply an Italian support system developed at the Opificio delle Pietre in Florence, and which we have seen today. I will only briefly outline the technical aspects of this system, as it is well described in previous publications and is far better represented by others in the audience. With this system, the panel is held against a custom-built solid wood strainer that is shaped to match the curvature of the panel. The panel is attached to the strainer by many custom-sized spring mechanisms, in this case 100. The system permits the panel to safely flex in response to slight variations in temperature and humidity while providing necessary restraint and support. These characteristics are essential when addressing the structural needs of extremely thin panels that present some movement and take on a natural curvature but cannot safely hold their own weight. When choosing this system, though, consideration must be given to the fact that with it, the range of flexibility is limited by the established curvature of the strainer and the limits of the spring system. I chose the system because the panel was flimsy and limp, weighed down by its own weight and unable to support itself. It needed a solid support that would establish a baseline curvature and carry the weight, allowing the release of the forces that were causing the paint layer to blister. In this particular case, the strainer and spring mechanisms worked well. The overall movement of the panel was not extreme because the panel could no longer react as a single large panel of healthy wood due to the wood's relative thinness and highly deteriorated states. Here we see it after the completion of the structural work. We also see it being safely handled by two conservators at the museum. The second case is a painting belonging to a private collection. It is a Flemish panel dating to the 17th century. It measures approximately 115 centimeters wide and 85 centimeters high, with the grain direction running horizontal to the image. It was constructed of 3 very high-quality boards of oak. The panel had been thinned to approximately 5 millimeters and had been cradled. The paint and ground layers exhibited extensive flaking, tenting, and losses along 3 wide horizontal bands spanning the length of the painting. These damages were caused by compression of the paint layers from the movement of the wood support due to changes in relative humidity. Records show that the painting had already undergone multiple restoration campaigns, only to have the same problems reappear. After releasing the thin panel from the restraint of its secondary support, its movement was monitored over a period of a few months under conditions of stable relative humidity. It was noted that even with slight variations in the environment, the panel exhibited considerable movement ranging from almost complete flattening to a pronounced curve. It was decided that a system developed by Ray Merchant at the studio of Simon Bobak would best suit the needs of this particular painting. As with the previous case, I won't go into detail of the intricacies of the system. However, briefly, the system consists of wing-shaped flexible battens made of Sitka spruce that are held to the panel by 4 retaining strips. These are held in place parallel to the grain of the board with slotted retaining blocks that are glued to the board. Flexible secondary battens are attached at 2 points to each of the wing-shaped battens. Pressure is exerted from the back of each of these springs by the framing elements, in this case by a sheet of plexiglass. The downside of this system is that because the support is flexible, it relies on the framing elements to provide the necessary stability for the safe handling of the painting. This downside, however, is offset by the fact that the movement of this panel is not limited by the range of the previously described spring mechanism. The 2 lower images show the treated painting out in the side of its frame. Not limiting the movement of the panel was essential because, in contrast to the Mainardi panel, the oak of the Flemish painting was strong and in beautiful condition, despite being flimsy and very thin. As such, the panel reacted to changes in relative humidity as a single board with one homogeneous curve. The large size of the panel, in combination with its thinness, meant that the range of change in its curvature would be greater than that of the Mainardi. This was especially relevant to this painting, as it belongs to a private collection that was unfortunately destined to be in a relatively uncontrolled environment where it will be subjected to changes in relative humidity. The next two case studies presented are derivations from the support systems I have shown you already, especially the final one. The purpose of including these is not to show new techniques, but rather to illustrate how elements can be drawn from the other systems and tailored to suit the specific needs of a particular work of art. To define these needs, consideration is given not only to the physical qualities of the work of art, but also their context and their environment, as well as the restraints and resources available to the conservator at the time of treatment. This is a group of 3 curious small paintings by the American artist Joseph Decker. They are roughly dated between 1883 and 1885. All 3 paintings are owned by a museum that wishes to remain anonymous. However, once exhibited, all 3 paintings will be displayed together. Each depicts the head of a young boy, mouth wide open, engaged in various activities. Their titles describe the activities: boy at dentist, boy eating berries, and boy smoking. They are all painted on artist palettes. The treatment of these paintings not only required the design of a support that would serve to stabilize and preserve the structures, but it also presented an interesting challenge because of their unusual nature. An important element in the design of the supports was to maintain the integrity of the palettes not only as paintings, but also as painted objects. The new support system, therefore, needed to be easily removable. It also needed to provide a system by which the palettes could be mounted into whatever display construct would be subsequently designed by the museum. The 3 paintings were treated simultaneously. However, only one of the paintings, Boy Smoking, will be addressed here as it is the only palette made of wood. The other 2 were painted on paperboard supports. The support of Boy Smoking is a single rectangular board of mahogany with the grain running vertically with respect to the pictorial image. The hole in the palette is beveled along its lower edge, transforming the ergonomically contoured thumb hold into the lower lip of the boy. It is small, measuring 24 centimeters wide and 34.5 centimeters high. It is approximately 3 millimeters thick. The mahogany board had numerous splits running in the grain direction. Most of the splits had been glued back together in a previous restoration. However, portions of these splits had reopened, and there were new ones as well. The areas surrounding the open splits had taken on different curvatures compared to the overall bow of the panel, and the panel exhibited only very slight movement of the wood when its curvature was monitored. After repairing the splits, an attached flexible support was designed and constructed as an adaptation of the system used by Ray Merchant and Simon Bobak. The new system consists of 8 wing-shaped flexible battens made of Sitka spruce. They are held together by 3 retaining strips made of German oak. I adapted the system to make it more easily removable by pinning down the support to the mahogany panel using custom-built felted brass fittings that clip onto the pallet at 6 points. The brass fittings are attached to the flexible support in such a way that 3 of the 6 clips can slide up and down, allowing for the painting to be easily removed from its mount. Hanging clips were then attached to the mount so that it could easily be hung to a wall or other display case. The visible portions of the clips that hold the painting in place were toned to match the surrounding areas of the painting. Similar systems were constructed for the other 2 paintings, in the group, with the only difference being that they did not restrain the curvature of the boards. Instead, they simply hold the palettes onto a solid support shaped to the exact contours of the boards. This system worked well as it provided a slight restraint to the movement of the mahogany board and allowed for it to be safely mounted in any type of display. It also allowed for easy removal of the system so it could still be appreciated as an object. However, it only works because the pallet is so small and can be safely handled with care even without the support. The fourth and final project is a Florentine cassone panel by Apollonio di Giovanni, dated to approximately 1460. It is owned by the Birmingham Museum of Art. It depicts the journey of the Queen of Sheba. It measures approximately 43 centimeters high and 176 centimeters wide, with the grain running horizontally. It has been thinned to approximately 8 millimeters. The poplar panel has extensive worm damage throughout. It had been cradled and was consequently suffering from continual flaking of the paint and multiple splits in the support. Although the structural integrity of the panel was compromised by the worm tunneling, the panel did take on a homogeneous curve after the splits were repaired. Because its height was not so extreme relative to its thinness, it was structurally cohesive in its vertical profile. Its most salient problem was that its length, combined with its thinness, made it extremely difficult to handle. The panel also exhibited a considerable amount of movement when its curvature was monitored. The design of a new support system was additionally influenced by the restorations previously carried out on the panel. At some point in the past, the panel had been cradled. During another restoration campaign, the cradle was removed and 4 movable crossbars were installed in its place. Soon after the crossbars were added, new splits developed in areas surrounding the crossbars. Also, they offered no support to counteract the twisting of the panel along its length and, in fact, exacerbated the problem. Another important factor in the design of the support was that the painting needed to be treated under considerable time restraints with restricted access to tools and materials. Based on all these factors, I created a support which was an adaptation of a system that I learned from George Pisacca. A fiberglass featherboard is used as a lightweight support that does not need to be attached to the panel itself. It is held against the reverse of the painting by its framing elements, flexible clips. Here we see an example of this system on a small work by the American painter Melner Kilbourne Kellogg that belongs to the National Academy Museum of Art, New York, to which I applied this system. This system works beautifully with small paintings that can be easily handled outside of their frame because of their small size and structural cohesiveness. It consists of a single layer of featherboard, a lightweight fiberglass sheet, cut in the shape of multiple wings that is held against the reverse of the painting by a central wood spine that runs centered along the grain of the panel. It provides a delicate restraint to the movement of the panel and is extremely simple to make with little need for woodworking tools. I adapted the system so that rather than being held against the panel by the framing elements, the system was attached to the back of the painting at the horizontal central axis. A solid wood spine provided a safe means of handling the painting and supporting it in the frame, while the fiberglass wings offered some restraint to the panel across the vertical section. As with the previous example, the featherboard was cut in the shape of multiple wings. In this case, there are 2 layers with 17 wings on each side. The wings were cut so that the flanges of the top would cover the openings between the flanges of the bottom layer. Square holes were cut out along the central axis of the boards. These holes correspond to the placement of small square wood pegs that were glued at approximately 10 centimeter intervals along the length of the central axis of the back of the painting. Once the layers of the featherboard were fitted over the small wood blocks, the central solid wood spine was glued to the ends of the pegs, sandwiching in the featherboard and holding the layers against the back of the painting. This system allows the painting to be easily handled outside of its frame. It also offers a mechanism by which it can hang in its frame by supporting the weight of the painting on either side of the spine. The painting is held up against the frame by flexible brackets. These diagrams illustrate how the painting now fits in the frame. It is worth mentioning that, as with all the systems mentioned, the manner in which the painting is fitted in the frame is essential to the proper functioning of the system. In conclusion, the last two systems I have shown you are not necessarily systems that are meant to be repeated exactly. The main purpose for showing these projects is to illustrate the benefits of adapting panel support systems to suit the specific needs of each individual painting, giving consideration to the environment in which the paintings are likely to exist. Learning a broad range of techniques is essential in designing these systems. Working in private practice, the conservator often faces inevitable challenges brought about by constraints that are outside of the strictly physical requirements of the work of art. Having a wide vocabulary to draw from enables the conservator to be better equipped to improvise in an effective and responsible way, addressing the needs of each painting on a case-by-case basis. Opportunities for exchanges in techniques and approaches such as that provided by the symposium can only increase the technical vocabulary available to those of us working in this field. For myself, working in such a way would not have been possible without having been fortunate enough to have worked with and learned from some of the best experts in our field, and to them I am honored and forever grateful. Thank you very much.
Thank you very much indeed for sharing these case stories, and that's also always very useful to see how new solutions are being sought for and are being actually also executed in ways that seem to work brilliantly.